In June 1944, on the blood-soaked beaches of Normandy, Allied soldiers heard a sound that would haunt their nightmares for decades. It wasn't the explosion of artillery shells or the whistle of incoming mortars. It was something far more terrifying. A mechanical roar that tore through the air at 20 rounds per second. A continuous buzz that cut men down like wheat before a scythe. American veterans who survived that day gave it a name that perfectly captured its horror: Hitler's buzzsaw. This is the story of the MG42. The German machine gun so devastating, so psychologically traumatic, that it changed the way every army in the world thought about infantry combat. By the time you finish watching this video, you'll understand why this weapon, designed over 80 years ago, is still considered one of the deadliest machine guns ever created, and why modern militaries around the world still use weapons based on its revolutionary design. By early 1942, Germany faced a crisis that threatened to undermine their entire war effort. The German military machine that had conquered most of Europe in just 2 years was beginning to show cracks in its armor. The Wehrmacht was fighting on multiple fronts simultaneously, stretched thin from the frozen steppes of Russia to the scorching deserts of North Africa. The Soviet Union, despite suffering catastrophic losses in the opening months of Operation Barbarossa, was producing weapons at a staggering rate that Germany simply could not match. Stalin had moved entire factories beyond the Ural Mountains, out of reach of German bombers, and these relocated industrial complexes were churning out thousands of tanks, aircraft, and weapons every month. Meanwhile, the Royal Air Force was conducting increasingly devastating bombing raids on German industrial targets, and the United States had just entered the war with its virtually unlimited industrial capacity. German military planners knew the brutal mathematics of total war. They were being outproduced, outmanned, and slowly but surely, they were losing the war of attrition. The German High Command understood they faced an impossible equation. They couldn't match the Allies in raw numbers of soldiers or equipment. The Soviet Union alone had a population nearly twice that of Germany, and when you added Britain, America, and the other Allied nations, the disparity became overwhelming. Traditional military thinking would suggest this was an unwinnable situation, but German strategists believed there was one possible path to survival: technological superiority. If they couldn't field more soldiers, they would give each German soldier weapons so superior, so devastating in their effectiveness, that one German could match 5, 10, or even 20 enemy soldiers. This wasn't just wishful thinking or propaganda. It was a calculated strategy based on engineering excellence and innovative military doctrine. The German General Staff issued a directive to their weapons manufacturers that seemed almost impossible: create a machine gun that could be produced quickly and cheaply, that would be more reliable than anything currently in service, and that would deliver firepower so overwhelming that a single weapon could anchor an entire defensive position. The fate of German defensive lines from the Atlantic Wall to the Eastern Front would depend on whether their engineers could solve this seemingly impossible challenge. Germany already possessed what many military experts considered the finest machine gun in the world: the MG34. Introduced in 1934, it was a masterpiece of precision engineering, capable of firing 900 rounds per minute with exceptional accuracy and reliability. German soldiers loved it, and Allied soldiers feared it. But the MG34 had a fatal flaw that became apparent only when Germany needed to produce them in massive quantities. Each gun required approximately 150 hours of skilled machining work to manufacture. The weapon used precisely machined components that demanded expensive materials and highly trained craftsmen to produce. Germany needed hundreds of thousands of machine guns to equip their expanding forces, but at the current rate of production, it would take years to manufacture enough MG34s to meet demand. The cost per unit was astronomical by military standards, and as the war dragged on and resources became scarcer, this became an increasingly critical problem. In early 1942, the Mauser Weapons Manufacturing Company received what seemed like an impossible order from the German Army High Command: design and produce a machine gun that fires faster than the MG34. Costs half as much to manufacture, can be produced in half the time, and is even more reliable under the brutal conditions of combat. The specifications seemed contradictory. How could something cheaper and faster to make also be better? The military gave them a deadline that seemed deliberately unrealistic: 6 months. The engineering team at Mauser, led by weapons designer Werner Gruner, approached this challenge with a radical philosophy that went against conventional wisdom in firearms design. For decades, quality firearms had been synonymous with precision-machined steel components, carefully fitted together by skilled craftsmen. But Gruner realized that precision machining was actually unnecessary for most of a machine gun's components. What mattered wasn't the expense of the materials or the hours spent machining them to exact tolerances. What mattered was brilliant design that allowed simpler manufacturing methods to achieve the same or better results. Gruner proposed something that shocked the conservative military establishment: build most of the gun from stamped sheet metal. The same manufacturing process used to make tin cans and car body panels. Senior officers were skeptical. Stamped metal sounded cheap, disposable, the opposite of what German engineering represented. But Gruner understood something crucial about modern industrial warfare. In a total war scenario, the army that could produce good weapons quickly would outlast the army that produced perfect weapons slowly. He convinced the military to let him proceed by pointing out that they had nothing to lose. If his design failed, they could always continue with the MG-34. The prototype that emerged from Mauser's workshops in late 1942 looked different from any machine gun anyone had seen before. Where the MG-34 had smooth, rounded contours created by precision machining, the MG-42 had angular lines and visible welds where stamped metal parts had been joined together. It looked almost crude compared to its predecessor, and some officers privately doubted whether this stamped metal contraption could possibly match the performance of the beautifully crafted MG-34. Then they test-fired it, and everything changed. The MG-42 didn't just match the MG-34's performance, it exceeded it in almost every measurable way. The rate of fire was extraordinary, 200 rounds per minute compared to the MG-34's 900 rounds per minute. But it wasn't just the numbers that impressed the testers, it was the sound. When you fire a machine gun at 900 rounds per minute, you hear distinct individual shots happening very rapidly. But at 1,100 rounds per minute, that's 20 bullets per second, the individual shots blend together into a single continuous roar that sounds like nothing else in warfare. Allied soldiers who survived encounters with the MG-42 consistently described the sound in similar terms, like cloth being ripped, like a saw cutting through metal, like a continuous mechanical scream. The psychological impact of that sound would prove to be almost as effective as the bullets themselves. The revolutionary design that made this possible was based on a mechanism called recoil-operated, roller-delayed blowback. To understand why this mattered, you need to know how conventional machine guns worked. Most automatic weapons at the time used gas operation, where some of the propellant gases from firing a round were diverted through a small port in the barrel to cycle the action, extracting the spent cartridge and loading a new round. This system required numerous precisely machined parts, gas tubes, pistons, and complex linkages that all had to work in perfect harmony. The MG-42 eliminated almost all of this complexity. Instead of using gas operation, it harnessed the recoil force of the cartridge itself. When the gun fired, the barrel and bolt recoiled together for a short distance. Then a pair of rollers would cam outward, unlocking the bolt and allowing it to continue rearward while the barrel stopped. As the bolt moved backward, it extracted and ejected the spent cartridge, compressed the return spring, and on the return stroke, it stripped a fresh round from the ammunition belt, chambered it, locked the rollers back into place, and fired again. This entire cycle happened in a fraction of a second, and because there were fewer moving parts and no gas system to clog or malfunction, the weapon was extraordinarily reliable. The engineering elegance of this system becomes apparent when you look at the parts count. The MG-34 required 716 individual components to function. The MG-42 achieved superior performance with just 635 parts, and crucially most of those parts were simple stamped metal pieces rather than expensive machined components. Manufacturing time dropped from 150 hours per gun to just 75 hours. The cost fell from 327 Reichsmarks for an MG-34 to only 250 Reichsmarks for an MG-42. Germany could now produce 2 MG-42s in the time and at the cost of a single MG-34, and the MG-42 was actually the better weapon. This was the kind of engineering breakthrough that could change the course of a war. Production ramped up immediately, and by late 1943, the MG-42 was standard issue throughout the German armed forces. Over the course of the war, Germany would manufacture more than 400,000 MG-42s, more machine guns than Britain and America produced, of their primary types combined. But the incredible rate of fire created an unexpected problem that German soldiers discovered during the first combat trials. When you fire 200 rounds per minute, you're generating an enormous amount of heat. The barrel of an MG-42 could reach temperatures exceeding 500 degrees Celsius after firing just 150 rounds continuously. That's less than 8 seconds of sustained fire. At these temperatures, the barrel would begin to glow red, and if firing continued, it could actually warp or even melt. Traditional machine guns dealt with this problem by simply limiting the rate of fire or having long cooling periods between bursts. But the whole point of the MG-42 was sustained, overwhelming firepower. German engineers solved this with one of the weapon's most innovative features, a quick-change barrel system that was brilliantly simple and devastatingly effective. The barrel of the MG42 wasn't permanently fixed to the gun. It could be removed and replaced in seconds without any tools. A well-trained German machine gun team could swap a glowing hot barrel for a cool replacement in under 5 seconds. Each MG42 was issued with multiple spare barrels, and a proficient crew could maintain almost continuous fire by rotating through their barrel supply, letting each one cool while the others were in use. This quick change system would become standard on virtually every military machine gun designed after World War II. And it's still the primary method used to manage heat in modern weapons. The ammunition feed system represented another leap forward in machine gun technology. Unlike many Allied machine guns that used magazines, limiting them to short bursts of fire, the MG42 used a non-disintegrating metallic link belt. These belts could be linked together indefinitely, meaning the gun could fire for as long as ammunition was available, and the crew could manage the barrel changes. A standard German ammunition load for an MG42 position included several 50-round belts and multiple 250-round drums. In defensive positions, it wasn't uncommon for MG42 crews to have thousands of rounds stockpiled, allowing them to deliver sustained fire for extended periods. The belts fed smoothly through the weapon's receiver, and the robust feed mechanism meant that jams were rare even under the worst battlefield conditions. German soldiers quickly learned that as long as they kept the MG42 fed with ammunition and rotated the barrels properly, the weapon would keep firing reliably through conditions that would disable most other machine guns. The versatility of the MG42 was another crucial factor in its effectiveness. The weapon could be configured for multiple roles with minimal modification. Fitted with a bipod, it served as a squad automatic weapon, carried and operated by a 2- or 3-man team moving with the infantry. Mounted on a heavy tripod, it became a sustained fire medium machine gun perfect for defensive positions or providing supporting fire. It could be mounted on vehicles, from motorcycles to tanks, and even adapted for use in aircraft. This versatility meant that German forces could standardize on a single weapon type, simplifying logistics, training, and maintenance. American and British forces, by contrast, used different weapons for these different roles, each requiring its own ammunition, spare parts, and specialized training. The MG42's universal applicability gave German units a significant tactical and logistical advantage. The weapon's reliability under adverse conditions became legendary. The MG42 functioned flawlessly in temperatures ranging from -40 degrees Celsius in the Russian winter to +50 degrees Celsius in the North African desert. It worked when caked with mud, covered in sand, or frozen solid. The simple, robust mechanism and loose tolerances between parts meant that dirt and debris that would jam more precisely fitted weapons simply didn't affect the MG42. There are documented accounts of MG42s being pulled from rivers, shaken dry, and immediately fired without malfunction. Allied intelligence reports from multiple theaters of war consistently noted the exceptional reliability of the weapon, often contrasting it unfavorably with their own machine guns that were more prone to jamming and mechanical failure under battlefield conditions. June 6, 1944, D-Day, the largest amphibious invasion in history. American forces landing at Omaha Beach expected heavy resistance, but nothing could have prepared them for what they encountered. The beach was covered by interlocking fields of fire from German defensive positions, and at the heart of these positions were MG42 machine guns. One position in particular, designated Widerstands Nest 62, Resistance Nest 62, was situated on high ground overlooking the entire beach approach. Inside this fortified position, a handful of German soldiers manned an MG42 with thousands of rounds of ammunition and multiple spare barrels. When the first wave of American landing craft dropped their ramps, those soldiers opened fire. The sound of the MG42 carried across the beach, that distinctive ripping cloth sound that veterans would remember for the rest of their lives. Soldiers who survived the landing described bullets hitting the water around them so densely that the sea appeared to boil. Men were cut down before they could even wade ashore, and those who made it to the beach found themselves pinned down with nowhere to hide. For more than 3 hours, that single MG42 position dominated an entire section of Omaha Beach. Wave after wave of American soldiers attempted to advance, and wave after wave was forced to take cover, or suffered devastating casualties. The gun never seemed to stop firing, the crew efficiently swapping barrels and feeding new ammunition belts, maintaining almost continuous fire. Casualty estimates for that single position's engagement area exceed 200 American soldiers killed or wounded. The position was finally neutralized only when a U.S. Navy destroyer, seeing the desperate situation on the beach, moved to within 800 yards of shore, dangerously close for such a large vessel, and fired direct naval gunfire at the German position. Even then, it took multiple direct hits from 5-inch naval guns to finally silence the MG42. Stories like this played out at defensive positions across every theater where German forces fought. A single MG42 wasn't just a weapon, it was a force multiplier that could hold off attacks by forces many times larger than the crew operating it. The German military doctrine surrounding the MG42 was as revolutionary as the weapon itself. While Allied armies organized their infantry squads around riflemen, with the machine gun as a support weapon, the Germans inverted this concept entirely. In a German infantry squad, the MG42 was the primary weapon, and everything else existed to support it. The squad's riflemen weren't the main fighters. They were there to protect the machine gun crew, carry extra ammunition, and cover the MG42 while it repositioned. This doctrine, called Schwerpunkt or decisive point, meant that German defensive positions were built around creating overlapping fields of fire for their machine guns. The psychological impact of this doctrine was profound. Allied soldiers quickly learned that advancing against German positions meant facing those machine guns, and the mere sound of an MG42 opening fire could stop an attack before it really began. Let's examine how the MG42 compared to the primary machine guns used by Allied forces. The American military's primary machine gun was the Browning M1919. A weapon that had served admirably since World War I. It fired the same 30-06 cartridge as American rifles, making logistics simpler, and it was reasonably reliable and accurate. But its rate of fire was only 400 to 600 rounds per minute, roughly half that of the MG42. The British Bren gun, widely respected for its accuracy and reliability, fired about 500 rounds per minute from a top-mounted magazine that limited sustained fire. The Soviet DP-28, affectionately called the record player because of its distinctive pan magazine, managed around 520 rounds per minute but was heavy and cumbersome. None of these weapons could match the MG42's sustained firepower. More importantly, none of them had the quick-change barrel system, meaning they required extended cooling periods after sustained fire, a tactical disadvantage that could prove fatal in combat. The sound signature of the MG42 deserves special attention because it became a psychological weapon in its own right. When a machine gun fires at 400 to 600 rounds per minute, your brain can process the individual shots. Experienced soldiers could estimate how close bullets were passing by the sound and could time movements between bursts. But at 200 rounds per minute, 20 bullets per second, there are no individual shots to hear. It becomes a continuous sound, that distinctive buzzsaw roar. Allied soldiers couldn't judge distance or timing by sound because there were no gaps to listen for. The continuous noise created a psychological effect that went beyond the actual danger. Veterans consistently reported that the sound of an MG42 was more terrifying than the sound of artillery or other weapons. There was something primally frightening about that mechanical scream, something that bypassed rational thought and triggered pure survival instinct. Some soldiers would freeze when they heard it, unable to move or think. Others would panic and break from cover, often with fatal results. The Germans hadn't designed the weapon to be psychologically terrifying. It was an unintended consequence of the engineering, but they quickly recognized and exploited this advantage. The manufacturing efficiency of the MG42 had strategic implications that extended far beyond the weapon itself. By demonstrating that stamped metal components could produce a weapon superior to traditionally machined firearms, German engineers revolutionized weapons manufacturing. This lesson wasn't lost on other nations. After the war, the concept of using stamped components and simplified manufacturing became standard practice in small arms design. The famous AK-47, often cited as the most successful assault rifle ever made, owes much of its design philosophy to lessons learned from the MG42. The ability to produce effective weapons quickly and cheaply using less skilled labor and simpler machinery became crucial in the post-war world, and the MG42 proved it could be done without sacrificing performance. When Germany surrendered in May 1945, Allied forces captured thousands of MG42s, along with the factories that produced them and the technical documentation describing their design. What happened next is perhaps the ultimate proof of the weapon's superiority. American ordnance experts studied the MG42 extensively, and elements of its design directly influenced the development of the M60 machine gun, which became the U.S. military's primary machine gun for decades. The M60's gas system was different, but the quick-change barrel, the belt feed mechanism, and several other features were clearly inspired by the German weapon. Belgian arms manufacturer Fabrique Nationale analyzed the MG42 and created the FN Mag, which incorporated many of its concepts. The FN Mag became the standard NATO machine gun and is still in service with dozens of countries around the world. The Spanish produced their own version called the MG42-59. The Italians developed the MG42-59. The list goes on. But perhaps most tellingly, Germany itself never stopped using the basic MG42 design. After World War II, when West Germany was allowed to rearm and join NATO, they needed a new standard machine gun. They looked at modern designs from around the world, evaluated new concepts and technologies, and then decided to simply update the MG42. The resulting weapon, designated MG1 and later refined into the MG3, is essentially the same gun. The operating mechanism is identical. The overall design is the same. The primary changes were converting it to fire NATO's 7.62 meters ammunition instead of the German 8 mm Mauser cartridge, and adding a few minor improvements based on decades of experience. The MG3 remains in service with the German military today. More than 80 years after the original MG42 was designed, it's still considered one of the finest machine guns in the world. When a weapon design remains in active military service for 8 decades, when the country that originally created it sees no reason to replace it, and when that nation's former enemies all copy elements of its design, you've created something truly exceptional. The legacy of the MG42 extends beyond hardware into the realm of military doctrine and tactical thinking. The concept that machine guns should be the primary weapon of infantry squads, with riflemen in supporting roles, has been adopted by many modern militaries. The emphasis on sustained firepower over precision marksmanship in certain tactical situations, the importance of quick-change barrels for maintaining continuous fire, the use of belt-fed ammunition for squad automatic weapons, all of these concepts were proven and popularized by the MG42. Modern military forces around the world have machine gun doctrines that owe something to the innovations the Germans introduced with this weapon. The United States Marine Corps, for example, reorganized their infantry squads to emphasize the importance of the squad automatic weapon, a direct acknowledgement of the lesson the Germans had taught them on the battlefields of Europe and the Pacific. The MG42 represented a fundamental shift in thinking about military engineering and industrial production during wartime. It proved that in total war, the perfect can be the enemy of the good. That a weapon which is good enough and can be produced in large quantities will beat a perfect weapon that can only be made in small numbers. This lesson has been applied far beyond machine guns. Modern military procurement often emphasizes reliability, ease of manufacture, and logistical simplicity over absolute technical perfection. The MG42 showed that smart design can overcome limitations in materials and manufacturing capabilities, that engineering innovation matters more than expensive components. These principles guide military development programs around the world to this day. The weapon also demonstrated the importance of testing and refining designs based on actual combat experience. The quick-change barrel system, for example, wasn't part of the original design, but was added after early combat trials revealed the heat problem. This iterative approach to weapons development, constantly improving based on user feedback, has become standard practice in modern military forces. The sound of Hitler's buzzsaw hasn't been heard in combat for many decades now. The MG42 and its direct descendant, the MG3, fire the same type of ammunition as other NATO machine guns, so they don't have that distinctive sound signature anymore when using modern ammunition. But the echo of the MG42's influence reverberates through every modern military force on Earth. Every time an infantry squad advances with their machine gunner as the focal point of their formation, that's the legacy of German doctrine built around the MG42. Every time a machine gun crew swaps a hot barrel for a cool one in seconds without tools, that's MG42 engineering. Every time a military procurement officer chooses a design that can be manufactured quickly and cheaply without sacrificing performance, that's the lesson of the MG42. The weapon changed warfare not through any single battle or campaign, but by proving concepts that seemed radical at the time and are now accepted as fundamental truths of modern combat. The story of the MG42 is ultimately a story about engineering genius applied under extreme pressure. Werner Gruner and his team at Mauser had 6 months to solve a problem that seemed impossible: create a weapon that was faster, cheaper, and better than what already existed. They succeeded by questioning assumptions, by understanding that expensive and complex don't automatically mean better, by focusing on what actually mattered rather than what tradition dictated. The result was a weapon so effective, so influential, that 80 years later we're still using machines based on its design, still applying the lessons it taught about manufacturing and tactics, still acknowledging it as one of the greatest machine guns ever created. Next time, we're examining the German Tiger tank, the armored beast that forced Allied tank commanders to completely rewrite their tactical doctrine and caused such fear that American tank crews would sometimes refuse to engage when they spotted one. You won't believe what a single Tiger tank did to an entire British armored column in one of the most one-sided battles of the war. If you want to see more stories of German engineering that changed the face of modern warfare, subscribe to this channel and turn on notifications so you never miss an episode. This is German war engineering, where innovation met the brutality of total war and changed military history forever.